Hey you guys, welcome to another day of a lesson of algebra. Today we're going to be focusing on 6.2 arithmetic sequence in recursive form. Our vocabulary words for today is a recursive formula, recursive definition, argument, and justify. All right, so basically from last time that we focused on the lesson, arithmetic is basically adding or subtracting. Like I told you, keep that in mind on that section, adding, subtracting. So we're just focusing on that, and we're also gonna be doing the applying the explicit formula and converting it into recursive or recursive to explicit formula. All right, so just with that in mind, let's go ahead and start with our first example. Well, the main concept of this lesson, we have this. A recursive formula is a function rule that relates each term of a sequence after the first ones before it. If we consider the sequence 7, 11, 15, and 19, you can use the common difference of the terms of an arithmetic sequence to write a recursive formula. For the sequence, we have 7, 11, 15, and 19. The common difference is going to be a 4. Because from here to here, they're adding 4. And from here to here, they're adding 4. They're adding 4. Let n equals the term number of the sequence. Let a parentheses n the value of n terms of the sequence. So we have an example here. Your A1 is basically your first term. This one is basically representing your first term. The 2 here represents your second term. But as you can notice that your A1 will give you a value of 7. So 7 plus 4 will give us the next value, 11, as you can see here. If we continue this process of the sequence, let's say your A2 now is going to be 11. It's going to go right here. 11 plus 4 will give us 15. Then this 15 is going to go here, and add 4 is going to give us 19, and so forth and so forth. So therefore, we have this formula provided to us. It means that for every number of the term sequence n, you plug it in, and then the difference is going to be a 4. So for example, you plug in the 4 here. So 4 minus 1 will give us a 3. Let me write it down here on the side. So let's say we have this, the next term, 5. The term 5, based on this formula, we have a 5 minus 1, because we input this number inside here, since it's your n, and then we have a plus 4. So therefore we have a 5 minus 1 is 4 plus 4. Our A4 is giving us 19. So we're gonna put a 19 and then plus 4, and that's gonna give us 23. Okay, and it keeps going and keeps going, depending to what term you wanna end up with. So the recursive formula arithmetic sequence below is this, as a parentheses n minus 1 plus 4. The recursive formula together with the starting value, this is your initial value, defines the sequence. A general recursive definition for arithmetic sequence with the common difference d has 2 parts. The first term and the recursive formula. It's pretty simple if we just practice it. It's not that hard. So let's go ahead and practice some problems. Write the recursive formula for arithmetic sequence below. What is the value of a term? All right, so we have our formula provided to us. We notice that these numbers are increasing. They're increasing by 7. So therefore, this value, the value of 70, this is gonna be your A1. This value is your A2. This value is your A3 and so forth. So just keep that in mind. So if we label this A1, it gives us 70. If we continue this process, your A2 is gonna give us, well, there's a difference of 7. So it's basically A1 plus 7. So your A3 is gonna be your A2 plus 7. And then your A4 is gonna be your A3 plus 7. So technically here they give us 70, this is 77, 84, and 91. Because we're just plugging in this value of 70 inside here, and then the 77 here, and so forth. So if we try to write a formula to this, as you can notice that this part is a previous one. It's a previous term. Since it's gonna be the previous term, it means that you have to subtract the term. So in order to write a formula for this, you have AN equals A, whatever term you want to start with, and then subtract one of them, because you're, again, based on this, you're going to the previous term. Every new term that you're trying to find, you're going to the previous term and then add it plus 7. So therefore, this is your recursive formula provided to you. I'll put it here in the bottom. So this is your formula. Now it's telling us what is the value of the A term. So based on this formula, we're gonna continue all the way to the A term. So I'm gonna write it down here, A5, A6, and then I'll continue over here, A7 and A8. Now, you don't have to write all this information. We already know that it's gonna be the previous number plus 7. The previous term plus 7. I'm just writing down this extra information. So here you're gonna have 5 minus 1 plus 7. Then A, here we have a 6 minus 1 plus 7, which is again is the previous term. And then here we have 7 minus 1 plus 7. And the last one, 8 minus 1 plus 7. All right, so 5 minus 1, you have a 4. So the term 4, which is 91, plus 7 will give us 98. 6 minus 1 is going to give us a previous term, which is A5 plus 7. So it's going to be 98 plus 7 is going to be 105. Then the seventh term, 7 minus 1 will give us the term 6 plus 7. So 105. Since I ran out of space, I'm going to put it here. 105 plus 7 is going to give us 112. And your term 8 is going to give us the previous number, 112 plus 7, 119. So that's going to be your eighth term, 119. And this is your formula on the bottom. That's basically technically what you're doing. You just look in the previous number and adding it with the difference. That's all you're doing. This extra information is just to write it down so you could get to a formula. But if you try to figure out a certain term, you don't need to write down the formula all the time and figuring out what is the answer. I just did it for your own instructional purposes. So you could have an idea what's going on. Here we have the same concept. Write a recursive formula for arithmetic sequence. What is the ninth term of the sequence? So we notice that from here to here, they're adding 6. From here to here, they're adding 6 and adding 6. So that adding 6 is going to be your difference, your D. We already know that this is your first term, second, third, and fourth term. Based on the previous example that we did, we could follow along with these numbers. We need to write down a recursive formula. So our recursive formula in this case is going to be an equals a and minus 1. Technically, this is always going to be the same. Whenever you're writing down a formula, this part is always going to be the same. The only difference you're going to see is a D. That's where you're going to find the difference. So since they're going for a difference, you're going to put a plus 6. That's all you're doing. So technically, all of this stays the same and then just add plus 6. Since this is our first, second, third, and fourth term, let's look for the fifth one now. So A, 5 equals, you have A, 5 minus 1 plus 6. Which in this case is going to be A, 4 plus 6. And this A4 is going to be your fourth term, which is 21. Plus 6 is going to give us 27. That's the fifth term, 27. A6, A7. Let me do this one correct. And then we have 8, 8. And the last one, A9. All right, so let's follow along. We could skip this process and we could just move to here. A is gonna be a 5 plus 6 equals. So the previous number is 27 from here. And then we add the difference plus 6. In this case is 33. A7, we could skip everything, or we could just put in 33, then plus 6 will be at 39. Then we have 39 plus 6 is going to give us 45. And then the last one, which is your A9. 45 plus 6 is going to give us a 51. So here is going to be letter C. And your formula is basically this. All right. If you want to fill in the blanks here, it's optional. It's up to you. You don't need to. I'm just skipping some information for beginners that are still trying to understand this. So 6 minus 1 plus 6. Here you have a 7, so we're just gonna replace 7 now with a 1 plus 6. Here you have a 6 plus 6. And here you have a 8 minus 1 plus 6. This a becomes 7, close parentheses, plus 6. Then you have 9 minus 1 plus 6. And that becomes 8, the term 8, and then add a 6. That's basically what happened for those that are still trying to figure out what's going on. Again, do this slowly. If you don't understand it very well, do it slowly. It's pretty much straightforward. You just add in the previous number by the difference. All right, use the recursive definition. an equals an minus 1 plus 10. What is when a1, which is your first term, equals to 3? To find the first 5 terms of the arithmetic sequence it defines. All right, let's start with the a1. a1, we already know that it's a 3, value of 3. We need to figure out our a2, our a3, our a4, and our a5. Find the first 5 terms. So this is your first 5 terms. All right. Based on this formula, we're just gonna replace n with these numbers. With the number 1, 2, and 3. So you're gonna have a 2 minus 1 plus 10. A 3 minus 1 plus 10. A 4 minus 1 plus 10. 5 minus 1 plus 10. All right, our next step. We have a 2 minus 1 is 1 plus 10. This is 2 plus 10. This is 3 plus 10. This is 4 plus 10. Let me choose a different color. All right, so your A1 is already giving us a value of 3 plus 10. That's gonna give us 13. Your A2 is 13 plus 10 is gonna give us 23. So 23 plus 10, that's gonna be giving us 33. So 33 plus another 10 is gonna give us 43. So that's your 5th terms. Term 1, term 1 all the way to term 5. And this is your answers, all of this. Those are your answers. Again, you could go ahead and omit all of this and just add 10 to this number and you could figure out the next terms without doing all of this work. All right, so select a tool or technique to find the first 5 terms of the arithmetic sequence defined by the recursive definition. An equals an minus 1 minus 8 when a1 equals 100. So this is how you're starting. Again, start. That's your initial. This is your difference. I ran out of space. This is your difference. So therefore, since we started with 100, we did not start it with 108. We did not start it with 92. All right, so it's between A and C. Since you're subtracting 8 from 100, your A1 is 100. Your second term, if we follow the formula, you have, I'll put it in detail, 2 minus 1 minus 8. Then you have A, which is 1 minus 8. And then you have 100 minus 8. I don't like that 8. Let me go ahead and erase this 8. So we have 92. So our second term is not 108 because from here to here, you're adding the 8. And from here to here, you're subtracting the 8. From here to here, subtracting the 8, subtract the 8. All right. So it's letter C in this case. Now we're going to be doing a little bit of conversions. An arithmetic sequence is represented by a recursive formula. If the first term of the sequence is 19, write an explicit formula. So it already tells you first term is 19. So technically, your A1 is 19. And they're telling us to write down an explicit formula, which is this, basically. This is going to be considered your D, your difference. So to write down in a formula, you're just going to write down AN equals, your A1 is 19 plus N minus 1. Your difference is going to be a 12. So you're just going to put 12 and you're done because you're just writing a formula. You just write in a formula. You're not solving for anything. This explicit formula is in chapter 6.1 on the lesson. If you need to go back and review it, make sure you watch the video. All right, let's try this again. For the recursive formula, we need to find its explicit formula. This 2 is representing our D, and this is our first term. Here we do not start with 21. Take those two out. We have 21 and 21. Based on the explicit formula that we have here, it has a -1, not a plus. So D is out and you're left with A. Letter A. I'll just put that here so you can know. And I'll put this one like this. That's all you're doing. You're just converting it really fast. And our arithmetic sequence is represented by explicit formula. Okay, so now we're doing explicit to recursive. We know that this information here, that's gonna be your A1. This information here is gonna be your difference. Your recursive formula is basically, this section is gonna stay the same and you're just writing the difference. So in this case, you're gonna have your A1 equals 32, and your formula, which is your AN, again, all of this information will be the same. It's never gonna change. And then the difference is by, since we have a positive 22, you put plus 22, and that's it. Whenever your N is bigger than, or whenever your N is bigger than or equal to, in this case, it's gonna be, yeah, a 2. That's all you're doing because you're just writing the formula. Let's practice this one more time. This is gonna be your A1. So since A1 started with 76, did not started with 10. So it's out. And this section is your difference. You're adding the 10 because it's a positive 10, not subtracting it. So this is out and you're left with letter D. Just look for those minor details so you could do a process of elimination and you could come out with the answer. All right, let's work one more, and let's see. An arithmetic sequence is defined below. So your first term, it's an 8. And G parentheses n plus 1 is gonna give us Gn plus 7. Okay, for every n bigger than or equal to 1. All right. What is the value of the term G25, which is the 25th term? All right, so in order to do this a little bit much faster for us to work with, you could do one term at a time all the way to the 25th, like the way we were doing it on the, like here, like 1, 2, 3, 4, 5, all the way to the 25th, to the 8/25th. But that's gonna take forever. That's gonna take forever. Since we don't wanna do too much work, we could just use the explicit formula that is provided to us here. We could convert this formula into explicit, and that way we could find the 25th term without doing too much work. Okay, so in this case, we could just replace our n with 25, which that represents our 25th term. Our A1 in this case is going to be G1, which is 8, plus, and then we have the N is a 25, and minus 1. The difference here, if you remember, difference is basically this. This is your D. So you're going to have a positive 7. So here you're going to have 8 plus 24 times 7. And then you have 8. And then plus, let's see, so we have 24 times 7. Let's see how much is that going to be. That's going to give us 168. And then plus 8 is going to be giving us 176. 176. And that's it. So your 25th term is going to be 176. And that's all you do. You just convert it from this formula to explicit and then plug in the information and you're done. Okay. So thank you for watching. You have a great day. If you have any questions, please let me know. You have a good one. Bye.